Alex, welcome to Talk Python to me.
Thank you.
Yeah, it's fantastic to have you here. You have so many cool open source projects out there. We're here to talk about AnyIO, but actually several of them I've covered on Python Bytes on the other podcast that I run. And we've talked about SQL code gen and typeguard. And I didn't associate that with you specifically and back over to AnyIO. So yeah, a lot of cool projects you got going on there.
Yeah, too many actually. I managed to hand over a couple of them to other people. Seaboard 2 and Sphinx Autodoc type hints. Because I'm really stretched thin at the moment. I barely have time for all of the projects that I'm maintaining.
I can imagine. That's how do you juggle all that? I'm sure you have a full-time job and you have all these different projects, right?
Yes,
How do you prioritize
yes. Basically, I get the equivalent of a writer's block from time to time. So when that happens, I just either don't write code at all, or I just switch to another project.
Yeah, true. If you're talking about type hints versus async programming, like if you're stuck on one, you probably are not stuck on the other, right?
Yeah.
Yeah, interesting. Well, we're going to have a lot of fun talking about all of them. I doubt there's going to be any writer's block or speaker's block here, podcaster's block. It'll be good. We'll have a good time chatting about it and sharing it with everyone. Before we get to that, though, let's hear your story. How did you get into programming in Python?
I got into programming at the age of 8. It was on an MSX compatible machine. I started with BASIC, as so many others did. I did some simple text-based games at first, just playing around. At some point, I got Commodore's 128, and I did some simple demos, graphical demos with it. Then I got an Amiga 500.
Oh yeah, the Amigas were cool. They were special.
Yeah. So I dabbled in almost basic, then other kinds of tools also. I don't really remember that much of it. Then at some point, I did something with Mac, that is Mac OS Classic. There was this tool called HyperCard. It's a precursor for Flash, basically. So that's something I did some things with, simple games and whatnot.
Yeah, okay.
Then skipping forward a bit, I got into PC programming, like C, C++, mostly C. And then I think it was in the latter half of 2005, no, actually, it was much earlier, 1999. I started with Perl, hated it. Then I think the next step was in 2005 when I got to learn PHP. Hated that too. And then finally in 2007, I got to know Python, and then that was love at first sight, really. At that point, it was, I think, Python 2.5. And of course, I stuck with it. I did some Java professionally for a while, but I never really got to love it. It had this corporate industrial feeling to it.
Yeah.
Yeah,
I'm not dressed up enough to program my Java today. Let me go get my tie. I'll be right back.
Yeah. So Python was really cool. When I started learning it, my first practical application I made in 30 minutes after starting to learn it. So it's really staggeringly easy to learn. And that's one thing I love about it.
It really is. It's one of the few languages you can be really successful with a partial understanding of what's going on. Right? Mm-hmm. You don't even have to know what a class is or what modules are. You can just write a few functions in a file.
It's almost like it's English.
Yeah, indeed. Very cool. Raul out in the audience says, third time's the charm. The third language, you found the one you like there. Excellent. And how about now? What are you doing these days?
I've been working for several years on a project, very complicated project where, okay, this is always a hard part to describe it. It's a sort of working wellness application. I'm part of a bigger team. I'm the lead backend developer. It collects IoT data and visualizes it, and it provides all sorts of peripheral services to it. So this is the first time I really had to spread my wings with databases.
Oh yeah, okay. What technologies are you using there?
Well, on the back end we use Timescale DB, which is a PostgreSQL extension. This is for storing that time series data. Then on the back end, we use my framework called Asphalt. I don't know if you've encountered that one. I think it's really cool, but it's not in widespread use. Mm-hmm. It's not a web framework per se. It's more like a generic framework where you can compose applications from a mix of pre-made components and custom-made components.
What's it called?
Sorry? Asphalt.
What was it called? Asphalt, like the road?
Yes.
Better not spell.
That. No.
I'm guessing no. I did a search and I just found a snake.
Yeah, that's it. That's second link.
The Python, the snake on some asphalt road. Yeah, you got to be careful here. Okay. Is it a little bit like Flask, or what's the?
Well, Flask is a web framework. This is a generic framework. You can build any kind of applications with it. It doesn't have to be involved with web. You can either write command line
network thing, and not necessarily HTTP. So it could be UDP, or it could be just.
It doesn't even have to do any networking at all. You can build command line tools with it, and you can just have this mix of components and the YAML configuration to give settings to them all. I think this really would require a whole different session.
It does sound like it would be a whole different session, but this is news to me and very interesting.
Yeah, I haven't really advertised much. I'm working on version 5 at the moment, which does incorporate AnyIO support and all the. It brings the tech up to date with the current standards.
Okay. Yeah, this looks very asynchronous based. It's an async IO based micro framework for network oriented applications, it says.
Yeah.
And built upon UV loop, which is, how all the good Python async things seem to be backed these days. So it has a lot of sort of modern Python features. It's got async IO, it's got UV loop, it's got type hints, those sorts of things. When you started in Python in 2007, none of those existed. How do you see the recent changes to Python in the last 5 years or so?
I would say that Python has been developing at an incredible speed, and I really love it. So many useful stuff coming out with every release.
I agree. Yeah, the last basically from 3.5 to 3.8 or something. There were just so many amazing features that came out then. And now we're seeing these libraries built upon it, right?
Right.
Right. All right. Well, let's transition over to our main topic that we're going to talk about, which is what I reached out to you for, not realizing the other two interesting projects that I already gave a shout out to are also yours. We'll get to those if we got time. So with Python in 3.4, we had asyncio introduced, the actual frameworks that supported that. And then when it really came into its own was Python 3.5, when the async and await keywords were added to the language. And Python came out of the box with some support for great async programming. But then there's these other libraries that developed on top of that to maybe make certain use cases easier or add new capabilities. And AnyIO falls into that realm, right?
Yeah, so before we talk about AnyIO, we should talk about Trio. Have you heard about Trio?
Yes, I have heard about Trio. I even had Nathaniel on the show, but it's been a little while. It's been a while. That was back in 2018. I talked to Nathaniel. So Nathaniel Smith. So there's probably quite a few changes since then, actually.
Yeah.
So let's talk about Trio.
Actually, the last version of Trio was released just yesterday. The thing about AnyIO is that it's an effort to basically bring the Trio features to asyncio land. So Trio is fundamentally incompatible with asyncio. There is a compatibility layer called Trio asyncio, but it's far from perfect. So what AnyIO does really is allow developers to add these features from Trio to their asyncio applications and libraries one by one without making a commitment. For example, at my work, I use AnyIO for just a handful of tasks. I think we should talk about the features. So one thing, at least, I should say to dispel any confusion is that the Trio and asyncio are both like top-level async frameworks in that they provide an event loop, and AnyIO does not. So it's kind of a meta async framework. So it runs on top of
So it builds on top of the different frameworks, right? Okay.
Yeah, so it builds on top of these frameworks and their underlying primitives. So
yeah, so for people who are not familiar, Trio adds things like this concept of grouped tasks. So normally in asyncio, you start one task, you start another. They're kind of unrelated, but even if they're conceptually solving parts of the same problem. And then with Trio, you can do things like create what's called a nursery, and then you can have them all run, or you could potentially cancel unstarted tasks. And there's other coordination type of operations as well, right? That's the kind of stuff that Trio adds.
Yeah, so the point of AnyIO is, as I said, to bring these Trio features to asyncio.
Right. And because when you do Trio, it's an end-to-end async stack, which means
you are basically
things have to be built for Trio, right? It's like if I have, let's say HTTPX, it's I don't know how easy it is to integrate those kind of things that are expecting an async IO event loop over into Trio.
Yeah, so
I already have my own event loop running. Like it's hard to coordinate the tasks, right?
Right. So if you are talking about HTTPX, it had Trio and async IO backends. Now it defaults to the AnyIO backend. So it runs by default on both.
Okay.
So about AnyIO features, it provides trio-like task groups on top of asyncio. This in here we should mention that Python 3.11 has its own concept of a task group, but the mechanics are quite a bit different. That requires a bit of explaining.
Yeah, how's it work here?
The thing is, the asyncio task group, so not this one, but the standard library task groups, which are in Python 3.11, they basically just start normal asyncio tasks, and you can cancel individual tasks with using the task objects that come out of the create task method. What sets AnyIO task groups apart from asyncio task groups is the way cancellation is done. And since AnyIO was designed based on Trio, when you do start soon, it doesn't return any task object that you can cancel. Instead, cancellation is done via so-called cancel scopes. So each task group has its own cancel scope. If you cancel that, you basically cancel all the underlying tasks. But it goes even deeper because okay, this is a bit complicated, so bear with me. Cancellation is not done on a per task basis, but on a per cancel scope basis. So you can have cancel scopes nested, so that if you start a task and it starts cancel scope, you can just cancel that scope, and it cancels everything up to that point.
Okay, so like if I call a task, if I create a task, and then somewhere inside for it to do its job, it also creates a task. Those can be grouped into the same basic scope, right? So there's not these,
you don't even have to start another task. You don't even have to start another task. So if you cancel a cancel scope, then anything you basically await on gets automatically canceled. Bam. Which is this is called level cancellation, in contrast to the edge cancellation mechanism employed by asyncio. In edge cancellation, you just cancel the task once, and it gets canceled error raised in the task. So you can ignore it, which is, by the way, a bad thing to do. But then the task won't be canceled again, usually.
Yeah.
There are exceptions to this, which are a topic of debate in the community. But cancel scopes basically, they define boundaries for cancellation. So if you say you cancel a task group's cancel scope, only the tasks started from that task group are canceled. So when those tasks return back, so all the tasks are done, then the code just goes forward from this async context manager. Basically, when all the tasks are done, then however they end, unless some raised exceptions, that's a different situation. If they were either canceled or successful, then the code just goes forward to the all tasks finished part. Okay.
This is really neat. The other thing that's standing out here as I think about these task groups. So for those of you listening, you just create an async with block to create the task group, and then in there you could just say task group dot start soon and give it a bunch of async methods to start running. Right. One of the things that's cool about this is it automatically waits for them all to be finished at the end of that context manager, the with block.
The standard library task groups work the same way, actually.
Okay. And those are in 3.11?
Yes.
Which is not out yet, but October is coming very soon.
Yep. we'll see how the mechanism will work. There's a new mechanism for cancellation called uncancellation of tasks. It's not really battle tested. It's something that was added fairly late in the game to 3.11. So it's not yet clear if there are edge cases where it fails totally. This is also a debated topic in the community.
Sure. The other thing here that I wanted to ask you about is you don't say like create task.
Right. So this is a model.
You say start soon. Why do you say what's this like uncertainty about? Tell us about that.
Yeah. So start soon. It does the same thing as create a task, because creating task doesn't start running it right away. It starts only running it on perhaps on the next iteration of the event loop.
Right. Or maybe not. Maybe the event loop's all backed up. Maybe it's the it takes a while, right?
Yeah. So it's basically the same as a loop that calls soon. So you schedule a callback. That's all that tasks are. They are callbacks with bells and whistles. So start soon is modeled based on Trio, but I should mention that there's also a method called start, which works a bit differently. Yeah, this showcases the start method. So this is very, very useful, this feature is not present in the standard library task groups. So basically, it's very useful starting a background service that you need to know that the task has actually started before you move on.
Right. So in the example that you have on the docs here is you create a task group, and the first thing is to start a service that's listening on a port. The next thing is to talk to that service on the port. Right.
Yeah.
And if you just say kick them both off, who knows if that thing is actually going to be ready by the time you try to talk to it.
Exactly. This is something I use in practice all the time.
And this is different than what you would get just with the asyncio create task or whatever, right?
Yeah. And even the new task group feature doesn't have this.
So I guess you could, in the standard library, you could start it, and then you would have to just wait for it to finish, and then you would carry on. But it's like 2 steps, right?
The workaround would be to create a future, then pass that to the task, and then wait on that future. So it's a bit cumbersome, and then you have to remember to use a try except in case that that task happens to fail. Otherwise, you end up waiting on the future forever.
Mm-hmm. I really like this idea. Now, the other thing that I don't see in your examples here, where I'm creating a task group and starting these tasks and waiting for them to finish, is management of the event loop. Like, if I was doing it with my code, I'd probably have to create a group or a loop and then call some functions on it. And here you just use AnyIO. Where's the event loop being managed?
I'm not sure. What do you mean?
Well, like a lot of times when you're doing async stuff, you have to go and actually create an async event loop and then use the loop directly. And you're working with a loop.
There is that run command at the bottom.
Yeah. Okay. So basically, you just say anyio.run
or asyncio.run.
And I can, if even though I'm using the AnyIO task groups, I can still I can mix and match this with like more standard async IO event loops.
That's the premise. So you can just ease into it little by little.
Nice. Yeah. So for example, if I have a fast API web app, and fast API is in charge of managing the event loop, and if I've got like an async API endpoint, I could still go and use an AnyIO task group and get all the benefits in there.
Yep. I should mention that fast API also depends on AnyIO.
Oh, really? Okay.
Yes.
How interesting. Yeah, I've seen Sebastian Ramirez talking about some little functions that he wrote. And he's like, I would love to see these just get back into AnyIO. I didn't realize that Fast API itself was using them. But yeah. Okay, so very useful. We've got these task groups. We've got the concept of cancellation. Another one that's not exactly cancellation, but is sort of cancellation is timeouts. Do you want to talk about how you do timeouts?
Yeah, I meant to talk about that. As I recall, in Python 3.11, there is a similar construct. I think it was with timeout or some asyncio.timeout or something similar. I don't remember really. But what this move on after does is it creates a cancel scope with a timeout. So basically, this is a very practical use of cancel scopes. What it does is it starts a timer, and after 1 second, it cancels this scope. So anything under that gets canceled. So in this case, just that the sleep command gets canceled, and then the task just keeps going.
So the way you described it before, it sounds like if there was a bunch of tasks running, if any of them try to await something, they're also going to get canceled. Is that right?
In this case, you mean?
Yeah.
No, only the part that is within the with block.
Right. Well, that's what I mean. But if you had done multiple tasks within like the move on after, right? Like I say, I try to talk to the database, it's an insert a record, and I try to call an API, and the database times out.
Right. So whatever is awaiting when.
Uh-oh, Alex, did we lose you? Hey, Alex.
Hey, Alex. Are you hearing me now?
Yes.
Yes, I do hear you now.
Yeah, sorry.
There's an echo now.
Yeah, my headphones, they fizzle out sometimes. Sorry about that.
Yeah, no worries.
Yeah, no worries.
I'm trying to get them back.
Actually, there's a pretty serious echo.
Could you turn down the speakers, maybe? See if that
okay, helps. Are you hearing me now?
I hear you good, and I don't hear myself. Perfect. Let's. Sorry. Yeah, let's carry on. We'll just edit that out. Sorry, YouTube. It's live. It's going to stay there, but for the other audio, we'll edit that out. Okay, so yeah, you were telling me, but what happens if I have multiple things going on and it times out?
Yeah. So within a single move on after block, you can only have one thing going on, which is the await here. So even if you start multiple tasks from that task group, they are not enclosed within that cancel scope. I realized that cancel scopes are a complex and difficult concept, and I don't think I can adequately explain them, but I hope that this will at least give shed some light into them.
Yeah. Well, it's a really cool idea because your code could, it's async, so it's not as bad as if you were to like lock up waiting for an API call or something that's going to time out on the network eventually after a really long time. But
yeah,
cancellation. It's still you don't want it to clog up your code, right? You want to just say, sorry, this isn't working.
Yeah. One place where I often use a construct like this is finalization. So when you are closing up things, then you can use this move on after to set a timeout for closing resources. So
yeah, that makes sense, because you want to be a good citizen and in terms of your app and release the resources as soon as possible, like a database connection or a file handle. But if it's not working, like, well, I made a try at it. After a second, we're done.
Exactly. And also, I should mention that this is where AnyIO's biggest caveat lies. It is in finalization. I often run into problems with cancel scopes because the thing with cancel scopes is that when you run code within a cancel scope and that scope gets canceled, then anything awaiting on anything within that cancel scope gets always canceled time after time. So you cannot await on anything as long as you are within the cancel scope. And asyncio code is not expecting that. So it might have a finally clause where it does await, say, connection.close. But that also gets canceled if you are within an AnyIO cancel scope, and it's one of the biggest practical issues with AnyIO right now. And we are trying to figure out the solution for that. Just something to keep in mind when you are writing AnyIO stuff. But
yeah, that is tricky, right? Because you say, well, I'm going to try to call this this web service, and I'm going to wait it. And if it fails, probably internally, what you want to do is close the network connection as well, right?
Yeah.
But if you try to await closing the network connection, yeah. So what happens there? Does it eventually just get cleaned up by the garbage collector, or
well, garbage collector doesn't work that well with async stuff because the structures could be called in any thread, so you can't rely on that. You can't do any async callbacks in the destructor. So it's a good idea not to try any of that, and instead just raise a resource warning. So if you're writing AnyIO where code, you would have either this shielded cancel scope, or better yet, a move on after which shield true. So
what does that do?
That at least temporarily protects the task from cancellation. So let's say you have move on after say 5 and with shield true. It means that even if the outer cancel scope is canceled, your actual task will start running until it exits that cancel scope, or if the timeout expires. So you have a 5-second window to close any resources that need closing.
Got it. And so you just create you could do that, say, within your exception handler or something, right?
Yeah.
Okay.
Or actually, I think finally, a finally block might be the best place to do that, but depending on your use case, of course.
Yeah, of course. Okay. Very interesting. So all this stuff about task groups and scheduling tasks and canceling them, that's very Trio-esque, but it's also just a small part of AnyIO. There's a bunch of other features and capabilities here that are probably worth going into. Some cool stuff about taking async IO code and converting it to threads, or converting threads to async IO, and similarly for subprocesses. But let's maybe just talk real quick about the synchronization primitives.
Yeah,
these are things like events, semaphores. Maybe not everyone knows what events and semaphores are in this context. Give us a quick rundown.
Well, these are pretty much the same as they are on async IO. Many of them use just the async IO counterparts straight up. So events are a mechanism for telling another task that something happened, something significant happened, and they need to react to it. It's often used to coordinate tasks, so one thing doesn't happen before something else has happened in another task.
Yeah. Yeah, there might be two tasks running, and one says, I'm going to wait until this file appears, and the other one's going to eventually create the file, right? But you don't know the order.
Yeah.
So one option is to just do polling, like, well, I'm going to async io.sleep for a little while, and then see if the file's there. Try to access it, and do that over and over. A much more responsive way and deterministic way would be to say, I'm going to wait on an event to be set, and the thing that creates the file will create the file and then set the event, which will kind of release that other task to carry on, right?
Right.
Okay.
Right. Moving on, semaphores are mechanism for saying that you have this limited. You have a number limit. Let's say a connection pool or something, and you want to specify that whenever some part of the code needs access to this resource, it needs to acquire this semaphore. So you set a limit, and then each time task enters that semaphore, it decrements the counter. And when you hit the limit, then it starts blocking until something else releases it.
Right. So people might be familiar with thread locks or async.io's equivalent, where you say only one thing can access this at a time, so you don't end up with deadlocks or race conditions and so on. But semaphores are kind of like that, but they allow multiple things to happen. Say maybe your database only allows 10 connections, or you don't want to have more than 10 connections. So you could have a semaphore that says it has a limit of 10, and you have to acquire it to talk to the database. That doesn't mean it stops multiple things from happening at once. It just doesn't let it become 1,000 at once, right?
Exactly.
I really like this idea. And, I was showing some people some web scraping work with async.io, where it's like, oh, let's go create a whole bunch of HTTPX requests or whatever type of requests, something asynchronous, talking to some servers to download some code. And if it's a limited set, no big deal. But if you have thousands of URLs to go hit, well, then how do you manage not killing your network or overloading that? And the semaphore actually would be perfect. So for people listening, the way that you do it is you create a task group and then you pass the semaphore to start soon. That's really clean. And AnyIO takes care of just making sure it gets access and then runs and then gives it back. How's that work?
I'm not sure what sort of answer you are expecting, but as I recall, this current implementation is actually using the underlying async libraries events. So
okay.
There are actually methods to acquire and release these semaphores. And it just implements an async context manager that acquires it at the beginning and releases it at the end. There's an event involved for notifying any awaiting task that it has a semaphore slot available.
Yeah, it's super clean. And the fact that you don't have to write that code, you just say this semaphore is associated with this task through your task group.
Actually, semaphores are not associated with a particular task. That's what capacity limiters are for.
Okay.
So you can release a semaphore from another task, while capacity limiters are bound to the specific task that you acquire them in.
Okay. Yeah, and the semaphore example, was it being passed? Oh yeah, it's just being passed as an argument, isn't it, to the task, and it's up to the task to use it. I see. Okay, so this other concept, the capacity limiter.
Yeah. So this is from Trio. It's very similar to semaphore. So you can actually set the borrower, but in most circumstances you want the current task to be the borrower, and limiters are actually used in other parts of AnyIO as they are in Trio. For example, to limit the number of threads that you allocate, or limit the number of subprocesses that you spawn.
Sure.
But
you don't have too many threads. You don't have too many subprocesses, right? You've got 1,000 jobs, and you just for each thing and job start it in a subprocess. You're gonna have a bad time. Right.
So as the documentation says, they are quite like semaphores, but they have additional safeguards.
Such as?
Well, they check that the borrower is the same.
Okay. Yeah, that makes sense.
By default, they check that that the task they are used from for both acquiring or releasing are the same.
Yeah, nice. Okay, well, these I didn't know about capacity limiters. That's fantastic. I love the idea. Okay, let's jump over to, you talked about the threads and the subprocesses. Let's talk about this thread capability that you have here. This is very nice. The AnyIO.2 thread. What is this?
Yeah, so this is also modeled based on Trio. It's basically AnyIO's way of doing worker threads. So in async IO, you have these thread pool executors that do the same as run sync. Async IO's API is somewhat problematic because you have basically two methods. So you have I forget the older one. The newer one is called toThread. The first one was it run in executor, whatever it was. They both have their own issues. toThread doesn't allow you to specify any thread pool, so it always uses the default thread pool, and there is no way to add that to the API because it was done in such a manner. Then the older function does have this parameter at the front, but the problem is that it doesn't propagate context variables, unlike the newer toThread function. So context variables, if you don't know about them, they are a fairly recent addition to Python. They are basically thread locals. Are you familiar with thread locals?
Yeah.
They are thread locals,
but let me just make a comment for
yep.
people who don't know. Like, thread local variables, which also exist in Python, allow you to say, I'm going to have a variable, maybe it's even a global variable, and it's thread local, which means every thread that sees it gets its own copy of the variable and where it points to and what value it is. And so that way you can initialize something at the start of a thread. If you have multiple threads, they can all kind of have their own copy, so they don't have to share it. But that falls down because async IO event loops, when you await those, all that stuff is running on one thread, just the one that's running the loop, right? So that's what you're talking about, is that equivalent, but for async IO, right?
So context variables are a much more advanced concept. They basically, as you said, thread locals for async tasks. So
that sounds very tricky. I've thought about that. I have no idea how to implement that. So that's pretty cool. I guess Python would know.
Yeah, the thing is, the event loop, when it starts running task, when it switches between tasks, it runs that callback within that context that the task is tied to. And when you start to work with worker threads, then you need to see the same context variables in that worker thread, right?
Right.
So this has been somewhat of a problem because that older method in async IO for running worker threads, it doesn't propagate these variables, but the newer function toThread does. But then you can specify which thread pool you want to use.
Right. Okay. So it's similar to the built-in one, but it gives you more capability to determine where you might run it.
Yeah. So basically, when you call run sync, it allows you to specify a limiter, and it uses the default limiter, which has a capacity of 40 threads.
40?
Yeah, 40.
That seems like that seems like a pretty good default. Much more than that, and you end up with memory and
it was arbitrarily set to 40 but Nathaniel in Trio. So I just followed suit.
Sure. Yeah. So basically, if you've got some function that is not async, but you want to be able to await it so that basically run it on a background thread, here you just say AnyIO.toThread and then .run sync, and you give it the function to call. And now you can await it, and it runs on a background thread in this thread pool, which is really nice.
Yeah, that's how it works.
So one thing that I'm noticing a lot in the API here for AnyIO is often, now for the synchronous functions, it's completely obvious why you wouldn't do it. But even in the sort of creating tasks ones, what I'm noticing is that even the async functions, you pass the function name and then the arguments to like start soon, as opposed to saying call the function, passing the arguments and getting a coroutine back. Why does it work that way? It seems like it would make it a little less easy to use, like, say, type ins and autocomplete and the various niceties of calling functions in editors.
Yeah, there was a good reason for that. I can't remember that offhand, but at the very least, it's consistent with the synchronous counterparts, like run sync.
Yeah. Okay. Cool. All right. So we have this stuff about threads, and you have the toThread. Yeah. Also from thread, which is nice. What's from thread do?
Yeah. So when you are in a worker thread and you occasionally need to call something in the event loop thread, then you need to use this from thread to run stuff on event loop thread.
Right, because the worker method is not async. Otherwise, you would just await it, right? It's a regular function.
Right.
In that regular function, you want to be able to await a thing. You can kind of reverse back. I see. That's an interesting bidirectional aspect. All right, subprocesses. We all know about the GIL, how Python doesn't necessarily love doing computational work across processes. Yeah, tell us about the subprocess equivalent.
Yeah, so this is a really relatively easy way to both run task in a subprocess and then opening arbitrary executables for running asynchronously. AsyncIO has similar facilities for running async processes, but these async subprocess facilities are not really up to par with, say, multiprocessing, which has some additional niceties like async shared queues and other synchronization primitives. Mm-hmm. But they are still pretty useful as they are.
Yeah. So basically, you can just say, you can just say AnyIO.toProcess run sync, and you give it a function, and now you can await that subprocess multiprocessing.
Yeah. So there are the usual caveats, like because they don't share memory, then you have to serialize the arguments, and that could be a problem in some cases.
Sure. So basically, it pickles the arguments and the return values and sends them over. Yeah.
Yeah. It could be even so that the arguments are pickable, but the return value is not, which obviously causes some confusion.
Yeah, absolutely. People maybe hear that pickling is bad, and you can have all sorts of challenges of like code injection and whatnot from pickling through security stuff. This, I would think, is not really subject to that, because it's you calling the function directly, and right, it's like
there's no way to inject anything bad.
Yeah, exactly. It's all the multiprocessing that's handling it anyway, so it should be okay. Yeah, cool. Another one that is pretty exciting has to do with file support. So we have open in Python. You would say with open something as f, right? But there's no async. equivalent, right? So
these file facilities are really just a convenience that wraps threads around these file objects. So if somebody wants to know, there is no actual async file I/O happening, because that's not really a thing on Linux, and even on Windows it has terrible problems.
Okay. So what's happening with this this AnyIO.open file?
Yeah. So it opens a file in a thread, and then this starts an async context manager that on exit closes the file. This file object
closes the thread, I guess, right?
Well, it uses throwaway threads, basically from the thread pool.
All right, I see. So it'll use a thread to open the file and get the file handle, and then throw away the thread, and then
return the thread to the pool.
Yeah, return to the pool, which is much better than creating it and throwing it away completely.
Yeah. So also that read call is done in the thread.
Okay, so it just is sort of a fancy layer over top of thread pool.
Yeah.
But it's really, really nice. You write basically exactly the same code that you would write with regular open in a context manager, but the async version. Although I got to say the opening part of creating a context manager here, you say async with, which people are probably used to, and then async with await open file.
The reason for that. The reason for that is because you can just do await open file and then go about your business, and then manually close the file. So
got it.
I'm not sure if there's a more convenient way to do this. I might be open to adding that to AnyIO, but for the moment, this is how you do it.
Yeah, you could probably wrap it in some kind of class or something that's synchronous, but then has an A enter. But yeah, it's I'm not sure if it's totally worth it, but yeah, that's quite the statement there. And then the other area that's interesting about this is if you want to loop over it line for line, instead of doing a regular for loop, you can do an async for line in file and then read it asynchronously line by line, right?
Yeah. So the aNext method just gets the next line in the worker thread.
Yeah. Yeah, this is fantastic. So people are working with files, they definitely can check this out. And also related to that is you have an asynchronous pathlib path.
Yeah, that's a fairly recent addition.
Yeah, it looks great. So you have like an async iterator, you have an async, is it a file, async read text, all built into the path, which, is like what's built into regular path, but not asynchronous. Yeah, quite nice. Let's see what else. We're getting kind of short on time here. What else would you like to highlight here?
I would like to highlight the streaming framework here, because it's one of the unique things in AnyIO.
Okay.
So
yeah, let's talk about it.
Trio has its channels, and then it has sockets and whatnot. But AnyIO has something that Trio doesn't have, and really async.io has some kind of streaming abstraction, but not quite on this level. So in AnyIO, we have a streaming abstract base class hierarchy. We have these object streams and byte streams. The difference between these are that object streams can have anything like the integers, strings, any arbitrary objects, and byte streams have only bytes, and they are modeled according to TCP. So with byte streams, you can send a number of bytes or receive bytes, but they might be chunked differently. These are abstract streams, so you can say build a library that wraps another stream. say you build an SSH client that creates a tunnel, and it exposes that as a stream. So long as you are able to consume a stream, then you don't have to care how the stream works internally, or what other streams it wraps. A good example of a stream wrapper is the TLS support. That's right there. So TLS support in AnyIO can wrap any existing stream that gives you bytes, even if it's an object, whether it's an object or byte stream. So it does the handshake using the standard library. Actually, standard library contains this SenseIO protocol for TLS. SenseIO protocol, if you are not aware of it, it's basically a state machine without any actual IO calls. It's a very neat protocol implementation that lets you add whatever kind of IO layer you want on top of that. So this is what AnyIO uses to implement TLS. So you have both a listener and a connect and a TLS wrapper. So any kind of TLS, you can even do TLS on top of TLS if you like. Not sure that's useful, but you can do it.
Super encrypted.
Yeah. So this is very flexible. We have all sorts of streams, even these unreliable streams, which are modeled based on UDP.
Really? Okay.
Yeah. So UDP is implemented by this using these unreliable streams. I don't think there are any more unreliable streams implementations than UDP. But yeah, there are. I'm really proud of this streaming class hierarchy, and it's too bad that there are no cool projects to show off this system, but maybe in the future we will have. Another thing that I would like to highlight is system of typed attributes. That has been really useful in practice.
Before we moved on to the type attributes, let me just ask you real quickly, can I use these streams and these bidirectional streams where you create like a send stream and a receive stream? Can we use those across like multiprocessing or to coordinate threads?
Sadly, no.
Right?
Sadly, no.
Okay.
This memory object stream is, as they call it in Trio, a channel. This is one of the most useful pieces of AnyIO, really. I use this every day at work. So these are basically queues on steroids. Unlike asyncio queues, you can actually close these. You can clone them, so you can have multiple tasks waiting to receive something, like workers. You have multiple senders.
Like a producer consumer, or like some things are put it in, but there's like 5 workers who might grab a job and work on it.
Yeah, you can have 5 consumers and 5 producers all talking to each other. Yeah, and then you can just iterate over them. Also not possible with queues. And then you can close the queues, streams, so that when you iterate on them, if all the other ends are closed, then the iterator just ends.
Oh wow! Okay, so if the send stream goes away, then the receive stream is done. It's at the end.
Yeah,
that's fantastic. Actually, I really like that.
Yeah, I think this is also coming to.
Go ahead. Sorry.
I think this is also coming to the standard library. At some point.
All right. Last thing we probably have for time for here that you wanted to highlight is typed attributes. What's the story of typed attributes?
Yeah. So if you knew about the asyncio extras in, I think they have both in protocols and streams. For example, with TLS, you want to get the certificate from the stream. Like if you have negotiated a TLS stream, you want to get the client certificate, right?
Mm-hmm.
So this you can do, but this is a type-safe way to do it. You can add any arbitrary extra attributes to a stream. Just declare it in the extra attributes method. But the niftiest part here is that it can work across wrap streams. So a very good example is that say you have a stream that is based on HTTP. You have an HTTP server and you have access to a stream, let's say WebSockets. Then you want to get the client IP address. Well, usually you may have a front-end web server like Nginx at the front. So normally what you will get when you ask for an IP address is that you actually get the IP address of the server. So what you need to do is look at the headers. So this is something you can do transparently with this type attributes. So basically the wrapping stream that understands HTTP, you can have that handle the request for the IP address, the remote IP address, and have it look at the headers and look for a forwarded header and return that instead.
Nice. Yeah. So let me see if I got this right here. So people are probably familiar with Pydantic, and Pydantic allows you to create a class, and it says what types are in the class and the names and so on. And those serialize out a JSON message. It sounds to me like what this is built for is when I'm talking binary messages over a stream, like a TCP stream, I can create a similar class that says, well, I expect a message that is a string and then a float. Read that out of the stream. Is that right?
Yeah, a good example here is if you go back to the streams part. Text streams.
Okay.
So this is something that translates between bytes and strings on the fly.
Mm-hmm.
So this is a perfect trivial example of a stream wrapper.
Okay. Yeah, so you have a text receive stream that will do the byte decoding.
Yeah.
Yeah, very nice.
And you don't have to care what's downstream of that. And even if you have 3 layers on top, you can just still ask for, say, client remote IP address. If there's a network stream somewhere downstream, that's the stream that will give you your answer.
Cool. Yeah, the stream work here is really nice. There's a lot of things that are nice. The coordinating, the task groups, the coordinating limitations, like with a limiter, capacity limiter. A lot of cool building blocks on top of it. And also the fact that this runs against or integrates with regular async IO means you don't have to completely change your whole system in order to use it, right?
Yeah.
Very cool. All right. Well, I think we're about out of time to talk about AnyIO. Do you want to take 30 seconds and just give the elevator pitch for SQL A Code Gen? This is a really exciting project that you created here.
Yeah, this is one of those side projects that are on the verge of a major release. So what this does is it takes an existing database, it connects to an existing database, reflects the schema from that, and then writes model code for you. The next major version even supports data classes and other other kinds of formats. It's
the
much
SQL
more
model one is the one that's most exciting for me because that'll give you Pydantic models that you can use with SQL model, which is very exciting.
Mm-hmm.
Yeah,
What
so
else?
nice. I mean, think if you're a consultant, or you talked about Java earlier, right? Imagine you've got like a Java code base and you want to do a proof of concept in Python and SQL Model or SQL Alchemy, and somebody says, well, why don't you try building a simple version that talks to our database? And if that thing has like 100 tables and complicated relationships, it's no fun to sit down. And like a big portion of that project might be just modeling the database. And here I can just say SQL A code gen, connect to Postgres, boom, out comes SQL Alchemy classes, right? That's a huge jump start for getting started.
Yeah.
Or if you're a consultant jumping into a new project.
Yeah, exactly. If you have a really large database, and this will save literally hours of your time.
At least hours, yes. And a lot of frustration, right? Because with like SQL Alchemy, you've got to have the model match the database just right. And this will do that for you. Yeah. Okay, super cool project. TypeGuard is another one you have. Not super complicated, but an interesting capability to grab on.
Yeah, also one of those that are on verge of a major release. I sadly have not had enough time to finish the next major version. And then there's, of course, Python 3.11, which brings a whole bunch of new features that I have not been able to yet incorporate into TypeGuard.
Okay.
And sadly, I also have not started using it myself. It's a sad story, really. But
yeah, okay.
It has the premise is that you have this PyTest plugin, and you activate it during the test run, and then in addition to static type checking your application, which you usually do with MyPy or what have you, you can also do runtime type checking, because the static tools don't always see the correct types.
Well, and you might not be in control of that, right? You might write a library. Your library might have types declared on what it's supposed to take. The person consuming your library has no requirement to run MyPy, and they have no requirement to make sure what they typed matches what you said you expect. And because they're hints, they're not compiled options in Python. It might, at runtime, you might get something you don't expect, even though you put a type there.
Yeah, exactly. So this is how you get a runtime assurance that you have the right type there.
Nice. So all you do with this TypeGuard library is you put an @typeChecked decorator on a function, and then go ahead.
Yeah.
What else do I got to do?
Actually, the best way would be to use the import hook. So there's an import hook that will automatically add these decorators while during the import, so you don't have to alter your code at all. There are some existing, open issues with that import hook, like somebody reported that this import hook is installed too late. The modules in question were already imported. So that's something I have yet to fix or find a workaround for. Sure. But that's the idea.
Right. So you can either use the decorator and be somewhat guarded about how you're doing it and only apply to certain parts, like say your public API. Or you could just say install import hook, and then everything that gets imported gets wrapped in the type checked decorator. And what that does is it looks at the type hints and the declared return value and will raise an exception if, say, you say that your function takes an integer and it's passed a string. That becomes a runtime error.
Right. Or you can just issue a warning.
Sure. The warning may be nice, but it's still, I think it's pretty cool. You can opt into having Python type hints become enforced, basically.
Yeah, what I use this for is in the Asphalt. When I accept the configuration for a component, I use this decorator or rather an assert, to check that the types are correct, so I don't raise any mysterious warning type errors or value errors further down the line, or even worse, at runtime.
Sure. Okay, that's cool. There is one of the features of Asphalt or highlights is runtime type checking for development and testing to fail early when functions are called with incompatible arguments and can be disabled for zero overhead. So it sounds like, you're maybe doing an import hook in development mode, and that's handling all this for you. Is that right?
Well, actually, in this current version, I'm using the assert. So if, in case you didn't know, when you have asserts, they are normally run without any switches to Python. But if you run Python without the debug mode, then asserts are not compiled in the bytecode. So just by using this switch, you can disable these potentially expensive asserts.
I see. Yeah, okay. I didn't know that. I'm familiar with that from C and C# and other compiled languages with their pragmas and that type of thing, but I didn't realize that about Python asserts.
Yeah, there's this one thing that actually, if you have this code, if under debug, then there's a bunch of code under that block, that whole block gets omitted from the compiled code if you run Python with the debug mode disabled.
Okay. Yeah, very cool. All right, Alex. Well, those are some cool additional projects. I feel like the SQL A code gen, we almost could spend a whole bunch of other time on it. Another one is the AP scheduler. Again, could almost be its own show, but we're out of time for this one. So thanks so much for being here. Now, before you get out of here, I've got the two final questions to ask you. If you're going to write some Python code, what editor do you use?
Well, I've been looking at the different editors available, and so far, PyCharm wins hands down. So it has so many these intelligent features and what have you that, for example, I use its database features to browse to my database. I use its refactoring features to change my code relatively safely, and its Docker support gives me auto completion. The list goes on and on and on, and most of these IDs are not nearly as sophisticated.
I agree. Excellent one. Now, notable PyPI package. I mean, we talked about a bunch. You can recommend any of these we talked about, or you can say
somebody else.
Interesting. Sure.
Well, I think I already mentioned Trio, but this is a difficult question, really. Maybe Poetry.
Okay, yeah, Poetry.
Yeah, so Poetry is something that I use for my application at work. It's the closest thing in Python to, say, Yarn. So I manage the dependencies and lock down the dependencies using Poetry. It's quite handy for that. I have some issues with Poetry, like when I just need to update one dependency, it updates them all, and small issues like that. But other than that, it's great.
Nice. Yeah, it looks really great. I know a lot of people are loving Poetry. It's a good recommendation there. All right, final call to action. People are interested in AnyIO. How do they get started?
Well, there's a somewhat of a tutorial there. I really don't have a really long tutorial unlike Trio, so I'm heavily leaning on Trio's documentation here because AnyIO has such a similar design to Trio. Then a lot of Trio's manual can be used to draw parallels to AnyIO. You can almost use Trio's documentation, the tutorial, to learn how AnyIO works.
yeah, it's highly inspired, right?
Right, and if anything else, then you should just come to Gitter. I think there's a link, getting help at the bottom.
Okay, yeah.
So there's a Gitter link, and I'm usually available there.
Great. Okay, yeah, very, very nice. And I'm guessing you accept contributions?
Sure.
Yeah. So yeah, let's see over here. We've got, yeah, what is that? 33 contributors. So yeah, excellent. If people want to contribute to the project, and maybe that's code, or maybe even they could put together a tutorial or something like that if they're interested.
Maybe, yeah.
Yeah, perhaps. Okay, excellent. Well, thank you for all the cool libraries and taking the time to come share them with us.
Thanks for having me.
Yeah, you bet. Bye. Thanks everyone for
Bye.
listening.